Yesterday we did a whole lot of theory, a whole lot of discussion about the trig ratios, the reciprocals, trig ratios, and inverse trig ratios. Okay, so just for a 1-minute review, sine, cosine, and cosine. Sine, cosine, tangent, you don't need to write this down, but tell me, what is the input for sine, cosine, and tangent? What type of a thing? An angle, that's right. Okay? It could be in degree or it could be in radians. Today we're just dealing with radians. Okay? Just get used to it. What is the output? What do those things spit out? If you say they spit out the ratio, that's right. That's true for sine, cosine, tangent, secant, cosecant, cotangent. Now, flip the script. Inverse cosine, inverse sine, inverse tangent. What do they input? A ratio. You feed them y over x, or r over y, or r over x, or y over x. You feed them a ratio. What do they produce? What do they output? An angle. Y'all are so good. Okay? But we found yesterday that sometimes when they spit out an angle, they could spit out maybe 2 different angles. Okay? So for instance, if I said, what's the inverse cosine of root 2 over 2, you saw that that occurred in the first quadrant and in the fourth quadrant. Okay? How do we know for inverse sine, okay, which quadrant the answer needs to be in? The mathematicians put limitations. First and fourth, that's right. So quadrant 1 and quadrant 4. But then I said with the quadrant 4 ones, they don't give the 270 to 360 degrees. They call this quadrant 4 up to quadrant 1 from, if you remember, negative pi over 2 up to pi, to positive pi over 2. So negative pi over 2 to positive pi over 2. All of this is on the video, which is in the process of being uploading up, yeah, if you want to watch. Inverse cosine. Which quadrants are we looking for the proper official answer for cosine? Inverse cosine. Quadrants 1 and quadrants 2. Quadrant 1, quadrant 2, which is, that's a nice easy 0 to pi, or 0 to 180, you're thinking in degrees. Inverse tangent, same as inverse sine. Yep. Quadrant 1, quadrant 4, namely the negative pi over 2 to positive pi over 2. Okay, lots of great stuff we discussed. We're about to apply it all. There's one other thing, it's going to show up on a problem. I might as well tell you right now, okay? If you remember the sine graph, good old sine, what were the range of values on that? Yeah, -1 up to +1, okay? So that means with inverse sine, and for that matter, inverse cosine, which looked very similar and had the same range, okay? I do have limitations about what I can put in there, okay? Because what it's outputting, the inverse sine, inverse cosine, it's inputting the ratio. It's inputting one of these things, okay? And so inverse sine, I can only feed it values between -1 and +1. If I try to feed it, if I try to input a value, say, of 2, essentially this is saying, what is the angle that will give me a sine of 2? And the answer is, there's nothing. There's no way in the world that you could have a sine of 2, right? So therefore, the inverse sine of 2 does not exist. Undefined. So let me say that again. This expression right here, inverse sine of 2 equals whatever, is the same thing as saying there's an angle somewhere where if you take the sine of it, you're going to get 2. Those two statements are equivalent. Okay? What's the angle? Anybody know? What angle here? What can I give you that's going to that will result in telling me the sine of that angle is 2? And the answer is there isn't one. You take the sine of anything, it's always going to give you a value between -1 and +1. So we'll see this. The same thing inverse cosine. If I said what's the inverse cosine of -1.1, you would say does not exist, undefined. Small little part. One of the problems deals with that. I figured it'd be better to deal with it now than when we get it. We'll be like, got it. These first couple problems are literally just, can you use your calculator to solve inverse trig function. You want to make sure that your calculator is in degree mode, radian mode. Can't do the first one, right? I guess there we go. That's why I said it. Inverse sine of 2.37, undefined. There you go. Can't do it. But what about tangent? Can you do inverse tangent of 2.69? You actually can. If you remember, the tangent graph goes from negative infinity to positive infinity. So somebody tell me in radians, what's your answer on that angle? I hear 1.21. All right. Are y'all comfortable now typing in numbers for inverse sine, inverse cosine? I'm pretty sure that you can handle problem types 1 and 2. Great. Let's go to something a little bit more interesting, like number 3. Number 3 says, find the exact value of the inverse sine of negative 1/2. Okay? Now, let's be very clear. This thing right here that we're feeding the inverse sine, the input, is what type of information? It's a ratio. More specifically, this is the ratio of what over what? Y over R. It's the ratio of Y over R. Now, if you look on your unit circle, we all know that the radius value is 1, okay? So, when R equals 1, then Y over 1 just equals Y. And so, we're looking on the unit circle where there is a Y value of negative 1/2. So, I'll write this down so you can have a little note to yourself later. So, look at a Y coordinate. I'll say look at Y equal to negative 1/2. And I want you to find the angle in radians. So this problem right here, find the inverse sine of negative 1/2, really means look at your unit circle at all those Y values along those points and find an angle in radians. Who has an answer for me for the angle? Shout it out. I hear pi over 6. Is there another one? Is there another Y?
Right.
What's that?
Yes, but it's not right.
That's fine. Tell me the wrong answer as well.
5 pi over 6.
Why is that not right?
Quadrant 2.
But is the sine of 5 pi over 6 negative 1/2?
Wait, what are you asking me?
Is that the 5 pi over 6?
Yes.
It has a Y value of negative 1/2.
Yes.
Right.
Oh, Y value of positive 1.
Oh.
That has a positive. That has,
Yeah, the other negative.
Oh, my bad. I said
is
the wrong
11
one.
pi over 6.
okay.
My
11 pi over 6. You were right, but for the wrong reason. Actually, you were wrong for the wrong reason.
Yeah.
But that's okay. Would you all agree with her? 11 pi over 6? That has a
Oh,
Y value
brother.
of negative 1/2?
We just ran into something.
Okay. Wait a second. Wait a second. Pi over 6. Does that have a Y value of negative 1/2?
Wait, no,
That one's just regular.
That's just regular 1/2. Okay. Maybe I said 1/2. I'm sorry if I said 1/2. Okay.
Yeah, that's why I was like, what?
7 pi over 6. Okay. Now,
We're all like.
that's all right. We are back on track here.
Okay.
So you're telling me that 7 pi over 6 has a Y value of negative 1/2, and 11 pi over 6 has a Y value of negative 1/2.
Yes.
Great.
But 7 pi over 6 is wrong.
Why is 7 pi over 6
because
wrong?
it's in quadrant 3.
It's in quadrant 3. Wrong. You are correct. That is wrong. 11 pi over 6, I'm guessing that's possibly in the 4th quadrant.
Yeah, it is.
Okay. Now, unfortunately, 11 pi over 6, it stopped at the right spot, but we cannot provide an answer of 11 pi over 6. Because remember, we can't go all the way around. We've got to go either down this way or up this way. Well, riddle me this. What we want to do is we want to find out this one.
Yeah, I was gonna say,
11 pi over 6 What's that angle in degrees? It's 330? Okay, it's 330 degrees, right? That sounds right. Okay. Now, that means we've got between the 360 and here, we've got like a 30-degree reference angle. Okay. What's 30 degrees in radians? Pi over 6.
So it would just be negative pi?
So this one right here would be negative pi over 6. It's so much stuff going on in this first problem. But I'm glad we were able to review all that yesterday. Inverse sine is only first and fourth quadrant, and you have to go from negative pi over 2 to positive pi over 2. So yeah, so there we go. We just finally solved it. Negative pi over 6. Students tend to get confused with sine and inverse sine because they're not sure if they're looking for an angle or if they're looking for the y value or which one's which. So what I'm going to try to do on all these problems, I'm going to say, look at this, find this, just to be extremely over communicable here. All right, so let's look at number 4. Find the exact value of the inverse sine of root 3 over 2. Now, same kind of thing. Inverse sine is accepting a ratio. That's the y over r value. Or on the unit circle, essentially it's the y value. Y is equal to root 3 over 2 because on the unit circle the radius is 1 all the time. So we're going to look at y values equal to root 3 over 2. And somebody tell me, what are we going to find? Find the angle. Because this says inverse sine of root 3 over 2. So theta equals, give me 2 answers here, folks. 5 over 3 and 2 pi over 3. If I were to guess, I'd say this one's probably in the first quadrant, this one's in the second quadrant. No second quadrant for you. Inverse sine is only first quadrant. And hey, that's already exactly the type that we like. So pi over 3 is our answer. That one's much better. Now, yesterday, didn't we walk around the unit circle writing all those tangent values?
Yes.
Yeah, you're going to be glad that we did. All right? Now, the tangent of inverse tangent of root 3. Now, some of you might be thinking,
Wait a minute.
Yes.
something, I think we can do something with this. And the answer is yes, you can, but
Inverse tangent.
the tangent of the inverse tangent. So what this is I'm feeding this in a ratio, right? Inverse tangent is going to spit out an angle. And then I'm going to take the tangent of that angle.
Fun.
So it's sort of like I've got something,
Okay.
and I'm going to I'm going to unwrap it, I guess, and then I'm going to wrap it back up again. Or maybe I'll do the reverse. I'll take something and I'll wrap it up and then I'll unwrap it. Whatever. Anyway, so we know that inverse tangent, we're feeding it, we're inputting a ratio. And what is that ratio, class? The tangent ratio. It is root 3.
Okay.
Yep. Okay. Yeah, it's the y over the x. Now, I think you all went around your unit circle yesterday and made very clear that you had either root 3 or root 3 over 3 or 1 or negative 1 or
0 or undefined.
yeah, absolutely. Okay. So according to this, we have tangent of some angle right here. But I need to, this part here, just like problems 3 and 4. So let's figure out what angle that is. So what angle do you all have, looking at your trig chart, has a y over x value of root 3? Say again?
You asking for radians?
Yes, in radians.
Okay, pi over 3.
And anyone else? Say it again? Yep.
4 pi?
4 pi over 3, is that third quadrant?
Yes.
Yeah, those are your 2 locations. Of course. Alright, which one of those do we like for inverse tangent? Pi over 3, because it's the first quadrant. Okay. So, here it's saying, alright, so we've found out what this inner part is. Inverse tangent of root 3 is pi over 3. Now, I want to take the tangent of pi over 3. Let me be clear about what this means. We've done this for a while, Pop. That's okay. I want to look at theta equals pi over 3, and I want to find the ratio y over x. Right? So once again, I've got tangent of pi over 3 means look at the angle pi over 3 and find the y over the x value. Okay, so the y over the x value, the y value is root 3 over 2. And what's the x value? 1/2. So that's equal to root 3 over 2 times the reciprocal, 2 over 1, which equals root 3.
Wait a minute.
Wait
a minute.
It seems like we did a lot of unnecessary.
What if I've got something and I box it up, and then I do the exact reverse process of it, of unboxing it? What am I left with?
The thing.
The thing you had at the beginning.
I'm upset.
See what we had? We had the inverse tangent of root 3, and then we took the tangent of root 3. So yeah, anytime you take the inverse tangent of the tangent or the tangent of the inverse tangent, you're left with whatever you had to start with. It's the same thing as if you had 10 plus 5 minus 5. Right? Or 3
I was like,
times 7 divided by 7.
hold on.
Hold on.
Or 6 squared, then take the square root. It's, you know, 2 steps forward, 2 steps back.
Yeah, because yeah.
So there we go. So the answer is root 3, but go through that process.
Is that only with tangent and inverse tangent, or if it's like the sine of inverse sine is this? Will it
It's
be
exactly
the same?
the same, because you're saying sine of 3 pi over 4 means find the this is the angle, find the ratio. Okay, the ratio is going to be something y over r, right?
And then we find
But
that.
then I want you to find the angle that created that. So
that answer is 3 pi over 4. Well, on there.
yeah,
At least it's an easy thing.
absolutely. What about number 7? Oh yes.
If you look at the answers, they're like pi over 4, and they're very different from.
What about for that last one that we did? Did we get that one right?
Yeah.
Yeah.
Right.
That was fine.
That one.
But number 6 is not?
No.
Yeah.
Ooh.
You actually have
7
to,
is.
you actually have to take the y value and you actually have to put it.
Okay. Alright, so you're telling me that if we look at the end, okay, so, alright, well, yeah, I knew it was too good to be true.
I know, right?
Okay, so you guys tell me, what is the sine of 3 pi over 4? Root 2 over 2? Okay. So just remember, to go from this step to this step, sine 3 pi over 4, I'm looking at the angle, 3 pi over 4, and I'm finding the y value. So I've simplified it. Inverse sine of sine of 3 pi over 4, so now I just have the inverse sine of root 2 over 2. Now, what this means is, look at y values equal to root 2 over 2, find the theta, find the angle. So that's how we're going to solve inverse sine. So let's all look at our trig chart and tell me all of the locations where you have a y value of root 2 over 2. Call them out to me. Pi over 4 and? I think that's negative. 3 pi over 4.
See, that's why it's pi over 4 is because it's in the first.
Yep, because inverse tangent, or sorry, inverse sine can only give you first and fourth. Yep, so it's not this one. It's got to be this one. Thanks for catching that for us, guys.
Right.
Now, if it so happens that the angle that we're originally dealing with is between negative pi over 2 and pi over 2, then we might be in the sweet spot,
Like for the next one.
like number 7. See, the problem was 3 pi over 4 was over there in second quadrant. But this one here, inverse sine of the sine of an angle, it's the unwrap and then wrap it again kind of thing. And this guy is a good fourth and first quadrant angle. So if you want to play the game, you can play the game, but I'll tell you right now it's negative pi over 9. It's the same thing because that one is within that range. Okay? If you're not sure about that, we're gonna do some more here in a minute that'll make things really clear. Alright? My question, so inverse tangent, we know that is from negative pi over 2 to positive pi over 2. Is this within that range?
No.
I don't, maybe it's not, I don't know.
Wait.
Whoa, I don't even know if that's, you know what, who cares? Let's just do this one the long way.
No.
If we get, so, I'm gonna rewrite this as, I'll write the whole thing out. Inverse tangent of the tangent of negative 4 pi over 7. Oh, okay, this is good. We need to do this one anyway,
Yeah,
this is
we do.
weird. Okay. I personally don't like negative angles and stuff like that. You know what I mean? I'd rather give me the positive location of that. So, but I don't even know where negative 4 pi over 7 is. Just tell me this. Where is positive 4 pi over 7? Which quadrant is that? Is it in second quadrant? Is it one of the ones listed?
No.
Oh, it's not even listed?
No. That's mine.
Yeah, there's two like that on Alex, where it's not.
So it's not even on the unit circle?
Yeah, it's not on the unit circle.
Ouch. Ooh. Okay. Should we turn it into degrees? Yes.
Isn't this like where you have to add or subtract 2 pi to make it down to where it's in the circle? Like if it was over 360 degrees?
Possibly.
That's still not.
Yeah, we could do that. Let's just, yeah, okay, so you're saying negative 4 pi over 7, you just want to add 2 pi to it?
I don't know.
Yeah, that like that should get us into the same exact location. Okay. So we got negative 4 pi over 7 plus this would be 14 pi over 7. Okay. So negative 4 plus 14, so we've got 10 pi over 7. That should be the same exact location.
Should we, wait.
So, okay, well, first off, let's just convert that to degrees. Alright, well, first question. Are y'all in agreement with what Janie said? Let's just add 2 pi to figure out where we get. Okay, so let's convert 10 pi over 7 radians to degrees so we can at least get an idea where this is. So I want to get rid of radians, and I want to go to degrees. So 180 over pi, that's radians to degrees. So somebody tell me, what is 10 times 180 divided by 7?
Oh, 257.
It's right here in the middle.
257?
Yes.
Point,
0.14.
and it keeps going.
Yes.
Oh, yuck, it's not even a nice round.
Right?
Mm.
This is disgusting.
Okay, so which quadrant are we in?
Third one.
Third.
We can't be the second, that's too far.
257, so we gotta be third quadrant, so we're right here somewhere. That's 180, this is 270, so yeah, we're somewhere around here. So we've got 10 pi over 7. And this isn't on your unit circle?
No.
Can we just type this in the calculator?
Let's see.
Oh, I tried that.
You can playing us this whole
I'm
time.
gonna cry.
Negative 1.751.
Oh, but they want the answer in terms of pi, right?
Yeah, I don't know how to do that.
Hmm. Okay. Well, alright, here, we've gotta roll with some other stuff here, so let me just tell you, so I got a whole other sheet here for you.
Oh.
Let's think about this real quick. I wanna figure out what this angle right here is. because then I can deal with all of my trig stuff. Okay, I know that this region right here is pi. So the whole thing is 10 pi over 7. So 10 pi over 7 minus pi should give me this theta ref right here. Agreed? Okay, so 10 pi over 7 minus 7 pi over 7. 3 pi over 7 is this angle right here. We have a 3 pi over 7 is my angle right there. Now, here's the thing. The tangent of 10 pi over 7 is going to equal the tangent of 3 pi over 7. So the tangent of this angle right here, tangent is the y value over the x value. If I just had this guy right here, I would have the y value over the x value. So are y'all in agreement with me that the tangent of 10 pi over 7, there's that large angle, would be the same as the tangent of 3 pi over 7 because that's this little guy right here. Now you might say, I don't know about that because the tangent of 10 pi over 7, this is going to be negative and this is going to be negative, right? But you still have a negative y over a negative x. And here I just have a positive y over a positive x. Well, those negatives would cancel each other out. Okay? So if everyone can agree that the tangent of 10 pi over 7 equals the tangent of 3 pi over 7, then I can rewrite this problem which says find the inverse tangent of the tangent of negative 4 pi over 7. I can write this as find the inverse tangent of the tangent of 3 pi over 7. So what we said is negative 4 pi over 7 is equal to 10 pi over 7. And we said that the tangent of 10 pi over 7 is the same thing as tangent of 3 pi over 7. And so now 3 pi over 7 itself is in the first quadrant. So we're saying what's the inverse tangent of the tangent of 3 pi over 7? And the answer is 3 pi over 7?
Yeah.
He's like, I know.
It is. Let's hope when you roll the dice you don't get another problem like that. But if you do, you've got the example. It looks like it was just a matter of finding the reference angle, and that was a match for us. Okay? Lots of good stuff going on there. Let's keep going. Oh, you're gonna need one more. The good news is these are just one examples, or maybe two examples of each. On Alex, you have unlimited examples. Alright. Alright, class, we're really going to fly through this one. Are you ready? It looks a little bit harder,
My gosh.
but we're not going to do all of them because there's a lot of repeats.
Yeah.
It looks harder, but it really isn't. The thing about this homework, someone asked me earlier, why do we need to do this? And I said, let me get back to you on that. But I don't know of someone that's ever specifically doing this particular type of a problem, the sine of an inverse secant and stuff like that, inverse secant of a sine, stuff like that. I don't know about that. However, this is going to make sure that you absolutely are rock solid on what it means to go sine, cosine, tangent, and inverse sine, inverse cosine, inverse tangent, which is used very frequently. Okay? So, we have things wrapped inside of other things here, but it's, if you notice here, it's no longer the sine of the inverse sine or the cosine of the inverse cosine. Now we've got mixed and matching going on here. And if we're mixing and matching, that's no big problem. The only catch is we just need to draw a picture. Okay? So the unit circle might not help us out a whole lot at this part. Okay? Now, so let's look here. This says find the secant of the inverse sine of 4 over 5. Now let's think about what this means. The inverse sine of 4 over 5 means I'm going to feed it a ratio and it's going to spit out an angle. Okay? So this is really asking what's the secant of theta. You're like, okay, what's theta? Well, I don't know. I'm going to focus in on this problem right here. It's whatever theta is, it's the thing that when you take the sine of it, it's going to give you 4 over 5. Okay? That's the ratio of the y over the r value. Okay? So a y value of 4, an r value of 5, and there's my theta. See if that makes sense to you. This diagram right here, theta, 4 on the y, 5 on the r, does that match this right here? Inverse sine of 4 over 5.
Wait, what?
I got a picture, you got a picture, draw a picture.
I'm sorry.
Alright. Now, take my word for it, we're just going to, let's do Pythagorean theorem real quick on this to figure out what this other side is. Or remember your Pythagorean triples. It's a 3. 5 squared minus 4 squared is 9, and square root of 9 is 3. Okay. So now, so there we go. We've got a nice little picture of what theta is, and they're wanting to figure out what is the secant of theta. Well, secant of theta, if you look on your trig chart, is the ratio of what over what? Hypotenuse over adjacent in terms of x, y's, and r's? R over x. So therefore, secant of theta is the r value, which is 5, over the x value, which is 3. So this is saying, give me a ratio, and then I'll tell you what the angle is, and then with that angle, I want you to find another ratio for me. And that's what we did. Let's do it again. Number 2. Find the exact value of the tangent of inverse cosine of 15 over 17. Okay? Well, inverse cosine of 15 over 17 means tell me the angle for which 15 over 17 is the x over r ratio. So, I'll write 15 right there for the x, 17 right there for the r, and then I'll use the calculator to figure out what the third side is. So what's 17 squared minus 15 squared? Then take the, well,
8.
8 is so 64, so it's 8. Is that a Pythagorean triple? Awesome. And I'll draw theta since that's what happens to be. So what this is asking is what's the tangent of theta? Y over x. And the y value is 8. The x value is 15. And you're done. So just to say it again, the inverse cosine is saying, what's the angle? What's the angle? What's the angle? Okay, we've got the angle right there. We actually really don't know what the angle is, but we say it's the angle that makes this triangle true. And it says, okay, fine. I don't even really need to know the angle. It's just like a placeholder. What's the rate? What's this ratio? What's the tangent ratio of that angle? And, oh, we can tell you that. 8 over 15. So some kind of neat stuff here. Number 3 is a little bit trickier. What do y'all notice is different about number 3? There's a negative. Where shall we choose to push that negative? To the numerator or the denominator? Because we can write this as negative 7 over positive 8 or positive 7 over negative 8, but we've got to make a choice. Anybody have an idea? Where cosine is x over r. Yeah, let's make that x negative. Remember, once upon a time I told you that that r value can never be negative. Okay? So we have an x value of -7. That triangle is going to look like this. -7. And our value of 8. We'll have to use Pythagorean theorem here to figure out what the y value is. So I'll write y squared plus -7 squared equals 8 squared. So y squared plus 49 equals 64. Someone tell me, what is 64 minus 49? 15, so y squared is 15. Ooh, that's not a perfect square, but that's okay. So y equals the square root of 15. So there's theta. I don't necessarily really need to know what theta is. They just want me to know what is the tangent of theta. And we know that tangent is the y value over the x value. So in this problem, that's square root of 15 over -7. All right, who's got a question? Yes, John.
For number 5, you have sine and then you have tangent. So
Okay.
how would you do that?
Great. Piece by piece. So now this is sine of 3 pi over 2. Let's say, how are you going to solve that, John? With the unit circle. What are you going to look at?
Oh.
Did you say, I'm going to look at theta equals 3 pi over 2?
Yeah.
And what are you going to find? What are you going to be trying to find here? So you found 3 pi over 2 on the trig chart, right? It's down there. Are you going to tell me the x value, the y value, the tangent value? What are you going to...
I see now.
Well, just tell me. What are you looking at?
We're looking for the sine.
Mm-hmm.
It would be -1.
Okay. So, is that the y value?
Oh, wait.
Is that the...
Yeah.
I feel like you're really... I don't know. I feel like you're not sure about that. Let me pause with you while you're looking at somebody else. Michaela, do you see 3 pi over 2 there on the trig chart? Can you find the y value? What is that y value?
-1.
Alright, okay, so we are in agreement with you, John. So the sine of 3 pi over 2 is -1. So that means I can write this here. What is the inverse tangent of -1? Now, to solve this, I'm looking at y over x values of -1, and I need to find the angles. Now, the tangent is really hard unless to do that unless you wrote them around on your unit circle. Did anybody write the tangent values? Tangent ratios? Hannah did. Anybody else write them? What are the angles where you find -1 ratio of y over x? I hear 7 pi over 4. Anywhere else? There should be 2 of them. And 3 pi over 4? I need someone to agree or disagree.
Agree.
Okay, Mason agrees. Now, which one are either one of those in the first or fourth quadrant?
Only one.
Which one?
7 pi.
Okay, 7 pi over 4. That's fourth quadrant, right?
Usually it's the one you did like on the other paper. The same ones, right?
The same kind of thing?
Yeah.
Okay, but unfortunately, if you remember, inverse tangent has to be between -pi over 2 and +pi over 2. It's in that same location, but we need to get the reference angle. We need to go, what's this guy right down here in order to figure out what the inverse tangent of -1 is. It drops down 45 degrees, right? Which in radians is
-5.
so -pi over 4. So the correct answer to this one is negative pi over 4. Cool. I know we're flying through. We got one more problem type. Are y'all ready? It's the same kind of thing, only it's like with algebra. Look at number 7.
Oh my goodness. Oh,
Not a big deal.
9. I'm scared.
Number 9 is easy, actually. Number 7, find the tangent of the inverse sine of 3w. Now, inverse sine, what is it taking as an input? Inverse sine takes as input, not an angle. Inverse sine inputs a ratio. So 3w, that's the ratio y over r. You're like, wait a second, how can 3w equal y over r? 3w over 1. Okay? So that's the y over r. So let's go ahead and draw that. 1, 3w. Would y'all agree with that? And I'll call this theta. Would y'all agree with that diagram? 3w right there, 1 right there. Let's go ahead and figure out what the x is using Pythagorean theorem. X squared plus 3w squared equals 1 squared. So that's x squared plus 9w squared equals 1. So x equals 1 minus 9w squared, sorry, x squared rather. And so x equals the square root of 1 minus 9w squared. Pause there. So this whole inverse sine of 3w is going to give us the angle. And then in turn we're looking for the tangent of that angle. That's no big deal. Tangent is the y value over the x value. So the y value is 3w. The x value we just determined is the square root of 1 minus 9w squared. So it's literally the same exact process that we were doing before, whether you're finding an angle or a ratio, but this time we've got some letters there, okay? The good thing about Alex is it has examples on all of these. You can see a similarly worked problem. Today we talked about inverse sine, inverse cosine, inverse tangent, how to solve those problems, as well as what we call wrapped problems, one inside the other, okay? Tomorrow's a knowledge check. How many topics? 245. 245 topics. These 2 homeworks are due on Friday.